Okay, so today is part 2 of rational equations. So based on what we did yesterday, we're actually not doing a whole lot of new stuff, which is nice for us. So some things that we have to deal with today is that on Friday, all of our equations always reduce to things like 2x is equal to 4, or 9x is equal to 2, or something like that. Things that are really easy to solve for x for. Today we're going to be dealing with things that reduce to quadratic equations. But that shouldn't be a problem because we just did an entire unit on solving quadratic equations. So we have 3 ways for solving quadratic equations. Justin, what's one of them? Yep, quadratic formula. Kevin, can you name a second one for me? Okay. What's the one where we have type 1 and type 2, and we look for things that add to something? Kevin? Yeah, so like factoring them, right? And then our third one is graphing. So I think even if we reduce to a quadratic equation, this should cause us no problems because we spent like 2 weeks solving quadratic equations. The other thing we'll be dealing with today is that all the problems we did on Friday always had a solution, and some of the problems we deal with today will not have solutions. Or when we solve for the solution, we'll find that it equals the non-permissible value. Okay? So just a few more things to think about today, but I don't think they're really that much harder. So let's do example 1b. So they ask us to solve the equation algebraically, and because we have 2 terms on one side, we know that we need to find that common denominator. So our common denominator, we know we need an x plus 1, and we need an x minus 1, and we need a 1, which we already kind of have because everything multiplied by 1 is just 1. And I'm going to keep these in factored form because we want to cross things out, right? So then we go 3 over x plus 1 multiplied by our common denominator. And then we go 1 over x minus 1 multiplied by our common denominator. And then we go 2 multiplied by our common denominator. Okay? And so we can cross these out right away. We can cross these out right away. And so we get 3 times x minus 1 plus 1, x plus 1 is equal to 2, x plus 1, x minus 1. Okay? So then we just want to distribute our 3. And we want to FOIL this. So we get 3x minus 3 plus x plus 1. And this FOILs so nicely because we know it's a difference of perfect squares. Okay, so then we want to simplify. So we'll go, okay, well, 3x plus 3 is 4x. Negative 1 plus 1 is negative 2 is equal to 2x squared minus 2. And then exactly. So in the past, we always said like, or on Friday we said, okay, put all the x's on one side, put all the numbers on the other. But because we know this is a quadratic, because it has an x squared, we know when we solve quadratics, we want it to equal 0. So we're going to go minus 4x on both sides and plus 2 on both sides. Yeah, you can move it the other way over and get like a negative x squared or negative 2x squared. Either way, you can get the same solution. So we get 2x squared minus 4x, and then our 2's cancel out. So here we can say, well, we get a GCF of 2x, and then we get x minus 2. So then at this point, we're solving it just like we would solve for what equals x in our quadratic equations unit. So we go like, okay, well, 2x is equal to 0. So x is equal to 0. X minus 2 is equal to 0. So x is equal to 2. Okay. So how we got those was, if you remember, we'd always go like this. Then we'd be like, okay, well, add 2 to both sides. So we get x is equal to 2. And then for the 2x is equal to 0, you can divide both by 2 and get x is equal to 0. Right? So this is kind of like a recap of a couple weeks ago. Okay? So these are our two answers, but we always have to think about our non-permissibles, right? So looking at our original equation here, in our denominators we have an x plus 1 and an x minus 1. So we go x plus 1 cannot equal 0, so x cannot equal negative 1. X minus 1 cannot equal 0, so x cannot equal 1. Okay? And because our non-permissibles don't match up with our solutions, everything is a-okay in our books. So if we flip the page, we'll do example number 2. Okay, so this one has one term on each side, so it's even in a lot of ways a simpler problem because all we have to do is cross multiply, right? So we go x squared minus 5x minus 6. And then when we're cross multiplying it, we're multiplying it by 1. So we actually don't have to do anything with that side. And then we go 2 times x plus 1. So we get 2x plus 2. And because we're dealing with a quadratic, we want everything on one side. Minus 2, minus 2. So we get x squared minus 7x minus 8 is equal to 0. And we can just factor this. Like, this is a good old type 1 factoring problem. So we're looking for two things that add to negative 7 and multiply to negative 8. And so we know one of them is going to be a negative number. Good. So we know that it's x minus 8 and x plus 1 are both equal to 0. So then we just solve it like we did before. We go, okay, well, x minus 8 is equal to 0, so x is equal to 8. X plus 1 is equal to 0, so x is equal to negative 1. And of course, we have to find our non-permissibles. So you know that x cannot equal negative 1, right? Because we have x plus 1 cannot equal 0. So at this point, we have to notice x cannot equal negative 1, and we get negative 1 as a solution. So we write rejection. So we reject the non-permissible. Okay? So x minus 1 is not one of our solutions. We only have one solution, and it's x plus 8, or x is equal to 8. Okay? And we can go like that. Okay? So just for the sake of your notes, you can write a little blurb about x is equal to minus 1 is a non-permissible and causes division by 0, right? Because if you remember to last week, that's why we said that our non-permissibles cannot be solutions, because that would mean that we're dividing by 0. And so therefore, not a solution. That's true. Yeah, number 1. That's true. Actually, yeah, let's do that. Let's verify number 1. So we're going to scoot back a little bit, because it is good practice to always verify. So we have to verify 2 different solutions this time. We have to do x is equal to 0. So that gives us 3 over 1, 1 over negative 1 is equal to 2. We get 3 minus 1 is equal to 2. 2 is equal to 2. So x plus, or x is equal to 0 looks good. And for our second solution, we go box these so we can see them better. We go x is equal to 2, so we get 3 over 3 plus 1 over 1 2. 2 minus 1. Oh. Wait a second. So we get 3 over 3 plus 1 over 1 is equal to 2. So it gives us 1 plus 1 is equal to 2. 2 is equal to 2. Yeah. So life is good when we verify and everything matches up. Okay, so let's scoot down to example 3. And we're just going to do B. You got it. First step is to cross multiply. So we can go x plus 2 is equal to 2 squared minus 4. And so we get x squared plus 2x is equal to 2x squared minus 8. And then because we have a quadratic, we want to make it all equal 0. So we go minus x squared from both sides, minus 2x from both sides. And we get 0 is equal to x squared minus 2x minus 8. So exactly, type 1 factoring. So what plus what is equal to negative 2? What times what is equal to negative 8? Okay, so what do you think, Josh? You got it. Okay, so because it's type 1, that means our factors are just x minus 4, x plus 2. So we get x is equal to 4, and x is equal to negative 2. Okay, but before we can accept these, we have to look at our non-permissibles, right? So for our first term, this one here, we want to factor this, right? So we know that x squared minus 4 is equal to x minus 2, x plus 2. And we know that neither of these can equal 0. So go x minus 2 cannot equal 0. X plus 2 cannot equal 0. So x cannot equal plus or minus 2. And then that also covers our second term here, because we know our non-permissible here would be x cannot equal negative 2. Right? So here's our 2 non-permissibles, plus or minus 2. So automatically, we can cancel that one out and write non-permissible. So we get x is equal to 4. And they even ask us to verify our solution, so we always want to do that. So we go verify. So we get 4 squared minus 4 under 4 is equal to 4 plus 2 under 2. So we'll get 16 minus 4 . So we get 1/3 is equal to 1/3. So life is good. Okay? So it's a nice quick lesson today. We only have one more example to do. Okay? So let's quietly focus for one more example. Okay, so this question has more than one term on each side. So that means we can't do the cross multiplication. We have to do the LCD. Luckily for us, though, our LCD is super easy on this one. Yeah. So it's just x minus 3. So we get to multiply everything by x minus 3. So we go plus 10, x minus 3, minus 4, x minus 3 is equal to 10x plus 4, x minus 3. Okay, so these cancel out. So this makes our life way easier now. We don't even have to FOIL anything. We do have to distribute this negative 4 to everything, so there and there. But that shouldn't be a problem. Okay? So then we get to simplify everything. And so this one isn't a quadratic. So we don't want to put everything on one side. We want to put all the x's on one side and all the numbers on another. So if we don't have any x squared, we want to try and split them up. If we have an x squared, we want them all together. Okay? So let's start simplifying this. So we have 8x minus 4x, so we have 4x, 10 plus 12, so 22, is equal to 10x plus 4. And then we want to subtract 4x from each side. Minus 22 is equal to 6x plus 4. And then we want to subtract 4 from each side. Minus 18 is equal to 6x. So x is equal to 3. Okay? So then we have to find our non-permissibles. So we get that x minus 3 cannot equal 0. So x cannot equal 3, which is the solution we found. And since that's our only solution, we know that we have no solution. Okay? So that's example number, or lesson number 8 now. So the homework is 1 to 5.